Okay. Right, so off of the test review, going to page 8, sorry, number 8 here. Okay, so volume of a cube is decreasing at a rate of 10 cubic meters per hour. How fast is the total surface area decreasing when the surface area is 54 square meters? Okay, so we can go ahead and start assigning these values to variables here. What do you think 10 cubic meters per hour is referring to? Yeah, so dV dt, okay? That's right, because decreasing, yeah. Keyword there. So cubic meters per hour tells us it must be dealing with time, volume dealing with time, decreasing tells us we're dealing with a negative rate. Okay, how fast is the total surface area decreasing? What are we looking for? dsdt. Surface area decreasing fast. Those are all words to indicate that time is involved. There's a rate of change involved. When the surface area is 54 square meters. That's just what? Just S, right? Just S. Okay. Okay, we're trying to get to dsdt. Let's go ahead and find each of the derivatives. Get all the calculus out of the way. So let's do S. Okay, what's the derivative of S?
How come not what the dsdt as to what we're trying to find, isn't that it?
Mm-hmm. Yeah, that's ultimately what we're trying to find, but we may need the V just in case. Okay, so we're not quite done yet here, right? S becomes dsdt, 12x. Good, dxdt. Let's see, what was your question again, Ashley?
Because I was saying, like in the beginning, when you were the question mark next to ds over dt, how come we're not done since we just found it? Okay,
because we're trying to get to a numeric value. We're not just asked for the derivative, we're asked for a numeric value, and we may not have everything that we need yet.
No, that makes sense.
Okay, let's go ahead and find dv dt, right? Just to get all the calculus out of the way. Okay, what does v equals x cubed become?
3x squared dx dt.
Good. dv dt equals 3x squared. Okay, we have everything laid out in front of us. Now we're just trying to piece together this puzzle here. All right, I want to find dsdt. I'm trying to find a numeric value for dsdt. I need x and I need dxdt. It'll be nice if the problem just gave those values to us, but they don't. They give us something that may be connected, but not explicitly what we're looking for.
You can find x by plugging in s for 50 plus x squared, and then from there you can use the volume formula.
Good. So we see that connection, right? See that connection there. So S is going to help lead us towards finding X. And then that X is going to help us towards finding dx dt. We have all this information at our disposal. Okay. So I'm going to start with S here. S equals 54. I know I can gather that X variable. Move over here. divide both sides by 6. Okay, does everybody follow steps so far? Okay, so we're making progress, right? We have that x figured out. That is a piece of the puzzle that we need. Okay, but we're still looking for dx dt. Like what Chloe said, we can involve that dv dt. We have our dv dt equation. Insert 3 in for x. Insert negative 10 in for dv dt. Find this missing variable, and if we're there, then we're in the clear. Okay. Okay, 3 times 9 is 27. Divide both sides by 27. Okay, so that's another piece that we need. I think we're getting close to our answer, right? ds dt, we found x using information from surface area. We found dx dt using information from dv dt. So 36, negative 360 over 27. Use your calculator to reduce it. Yes, calculator on the test. Yeah. And what's our unit of measure? Yeah, surface area, right? Focus on the word area, two-dimensional unit, meter squared. Time component per hour. Okay, does it make sense that we're getting a negative value? Good. Volume is decreasing, so everything is shrinking, right? Length is shrinking, surface area is shrinking. Negative makes sense. Okay. Questions with 8. All right, number 9. All right, jet A travels due east from San Francisco towards St. Louis. Jet B travels north from New Orleans towards St. Louis. We see a right triangle forming here. I'll go ahead and assign variables that I want to use. X for the horizontal, Y for the vertical, and Z for the hypotenuse. Okay, we know it's a Pythagorean theorem problem. We can go ahead and go through our derivative process, identify each of our variables. Okay. Jet A travels due east from San Francisco towards St. Louis at 500 miles per hour. What number is that going to relate to?
Yeah.
Okay, dx over dt. So we know it's 500, but we may have to make some adjustment. We'll just go ahead and put that there. All right, what's happening to x as time passes? Okay, so what's happening to the distance though? Decreasing. Negative, that's right. So this is telling us that jet A, as jet A travels, it's moving in a way where the distance between jet A and St. Louis is decreasing at a rate of 500 miles per hour. So we need that negative there. The tendency is we think, oh, I'm going to the right, so it's going to be positive, right? That's different. In this problem, we always have to look at the relationship of that length. If you see that length decreasing, you want that rate to be positive. But if you see the rate increasing, then if you see that distance increasing, then you want that rate to be positive. But in this case, it's decreasing, okay? Jet B travels due north from New Orleans to St. Louis, towards St. Louis, 600 miles per hour. This is relating to which variable?
dy over dt.
Good, dy over dt. And it's good, also getting closer, right? Find the rate of change of distance between two jets when they are 300 miles apart. How about 300 miles apart? Where's that going to go? When jet A is 100 miles. Yeah. Okay. Pythagorean theorem to get to y. Decimal value. All right, that's just coming from we involve Pythagorean theorem to help us solve for y. X squared plus y squared equals z squared. Okay, solve for dz dt by entering all this information into the derivative equation here. Okay, so a lot of numeric calculations in our calculator. Multiply and combine those terms. Divide the 600 over to the right side, and we can solve for dz dt. Okay. Any questions here? Okay, everybody good? All right, let's look at number 10. Okay, so this is a shadow problem. Shadow problems are all set up the same way. Yes, calculator. Okay, you're always going to set up every shadow problem in the same way. Just the vertical heights are going to change. 6 feet tall, 16 feet lamppost. Okay, next step, we want to create a ratio of similar triangles. Let me identify those triangles here. We got a triangle here. There's another triangle here. Okay, so we're going to say set up proportions. So height of the small triangle is to the height of the large triangle as base of the small triangle. What's base of the small triangle? Is to the base of the large triangle, x plus 1. Okay, questions there? All right, I'm just going to cross multiply, get all the calculus, algebra and calculus out of the way here. This is the equation that I want to work with, but I want to work with it without having to deal with all the fractions. So cross multiply. Distribute 6 through, combine like terms. Hey.
So if the graph is this, where it's just a bike, because please change it to sign. The only thing that changes in the equation is just the phase shift, right?
That's right. One.
And from cos,
And then sometimes you may try to change the reflection if it helps.
and then if it's from going from a cosine graph, like shifting to a sine graph, it's, or the sine graph is plus, and then the other one's minus.
So if I'm trying to go from a sine graph to a cosine graph, I typically want to I want to do a plus.
Mm-hmm.
If I want to get from a cosine to a sine,
It's minus because you're going right. Because you're shifting right.
Yeah, I'm shifting my cosine to the left, and then I'll also have to flip it as well. Because I'm trying to my cosine to, if I go to the left, I can then get that. Oh wait, the cos, yeah. If I shift to the left, my sine is going to be decreasing, right?
Mm-hmm.
So I will have to make it a negative as well. So a plus and a.
So cosine changing to a sine is you make the amplitude negative. But then for the other one, you just leave it.
Just leave it. Yeah.
Okay.
Okay, this is my equation. I can go into my derivative step. 6x becomes 6 dx dt. 10y becomes 10. All right, just a simple, easy derivative step here. Okay, so part A, at what rate is the length of the shadow changing? What are we looking for part A? Yeah, dy over dt, yeah. So dy dt is the rate of change of the length of the shadow. The man walks at a rate of 5 feet per second towards a street lamp. Yeah. Mm-hmm. Right, so the shadow is located here. Maybe I'll do a different color. So here's a person. The lamp, the top of the lamp is going to cast a shadow. That's this length right there. So if I can find the rate of change of y, that is going to match with the length of this shadow, increasing or decreasing. Okay. Okay. Dx dt is how fast a person is walking. So he's walking towards a street lamp. So we want to make that rate what? What did you guys say? Dx dt is. Okay, 5 feet per second. But what's happening to this distance as he's walking towards the lamp? It's changing, decreasing, negative. Okay, does that make sense? Okay. So I think we can insert and find our dy dt now. Divide both sides by 10.
How do I know like what to do with these?
Okay, so with this is really just saying remove the decimal.
Y equals.
Square root of x. So that's the equation you're working with. Find a derivative and then.
Would that be like 1 over x?
That's right. So
Okay.
every decimal replaced with x, and that's your
Okay.
equation. And then you want to choose the closest whole number to use.
Got it.
And then once you find your Canton equation, then at the very end, you'll just dump in.
That guy for the.
That's right. Just 36.1 though. Don't put square root. Just the 36.1 into your Canton equation.
Thank you.
Okay, so negative 30 over 10. So what's happening is as you are getting closer to the light source, the shadow is actually going to decrease. So if you think about it, like, yeah, keep it negative.
Yeah.
So I guess maybe something that you can observe is, like around noon, when the sun is right above your head, your shadow is like very short, very small, because you're right below the sun, and as you get further and further into the afternoon, your shadow is going to grow. So that's. Yeah, so the rate is actually gonna the sign's gonna actually match up, dy dt and dx dt. Okay, so dy dt is negative 3. So now part B, at what rate is the tip of the shadow moving? So tip of the shadow is based off of two things here. It's being influenced by how fast a person is moving and by how fast the shadow is growing. So those two things is going to cause the tip of the shadow to move at a at a faster rate than either the person or the length of the shadow. So the rate of the tip of the shadow, ROC, is rate of change of the tip, is dx dt plus dy dt. But actually, they're moving towards. Okay, so moving towards, the tip of the shadow is going to move, and it's going to get closer towards the source, so it's going to be a negative. That's fine, because we have two negatives there. We just add them together. Okay, any questions so far? This is page 14 in the packet. Linear approximation for F. Okay, so from those decimals, we can kind of have an idea what the equation is. Basically, if you replace all your decimals with variable x, that's your equation. So replace them, and I have y is equal to 1 over x root x. Okay, so that's the equation I'm starting with. Okay, everybody okay with that? Okay. We also want to choose the closest whole number value to use. X equals 2. So just from this information, we're going to find our order pair, find the derivative, find the slope, point slope form. Let's do the order pair first. 2 into the equation, I get 1 over 2 root 2. We'll leave it like that. Okay, everybody okay with that? So now I'm going to find my derivative. To find my derivative, I'm going to set up my equation. All right, I'm going to merge this together and get it ready for power roll. I prefer not to go through product and quotient if I can help it. So x root x, the same thing as x to the first times x to the 1/2. What do I do to combine those together? Yeah, add exponents. 1 plus 1/2 is 3/2. But it's still not ready for power rule, so I'm going to bring it up to the numerator. All right, so I'm now ready for derivative power rule. Bring down the exponent, subtract 1 from the exponent, minus 2 over 2. Do a little bit of cleanup. And now I'm ready to use my derivative to find my slope. Okay, that's really 32 square root of 32. Use your calculator. It's going to be okay, pull the 4 out. 4 times 2 is 8. 8 root 2. You can you don't have to clean up all the way, but I think calculator can do a lot of that work for you. It's okay to have radicals in the denominator. Okay, so we have our ordered pair, we have our slope. Let's build our tangent line equation.
My calculator was set to the wrong mode.
Oh, it was in radian, bro.
Yeah, it was in radian. I mean.
Oh, so radian should be okay. You want to go back and finish this?
Sure. Yeah.
Okay, I'm gonna use the space down here. I'm gonna get that y value to the right side. So there's my tangent line equation. It's a little messy, but we understand the process. And now the final step is the approximation part. Now we're ready for that 1.9. That 1.9 will replace the x.
Yeah, okay, so my question is, how come you don't put the 1 over 1.9?
The reason why is because we've already created a tangent line equation, which is we only care about where the graph touches this curve at a specific point. We don't care about how the rest of the graph looks. We just want to create a tangent line. So we don't want to involve the rest of all this mess in here. And also, we can double check ourselves too, because if we're to enter this messiness of a value, this numeric value should be pretty close to this numeric value, right? Because the actual value versus the approximation should be relatively close. As long as we're close to the source, and we are. We're close to the source of tangency, so we should be expecting numerically the same value, or numerically very, very similar values. Okay, that's just a messy numeric value. You can leave it in that form, or you can reduce it all the way down to a decimal.
Have a good weekend.
Okay, have a good weekend. All right, see you class.
We're gonna have to do one like number 4 on this.
Okay. Okay, so I'm going to stop this session here, but I'll be available after school and I'll just continue to do more problems. If you can't make it, I will record the sessions.